So the Module A, again, it's a little shorter than the chapters that are the other two for in the exam coming up next week. So we can cover all of that today, both the examples and kind of the PowerPoint. A lot of this will be review if you've had quant, which I think everybody has, except maybe Wyatt, he's in and down. So some of this stuff that we're talking about is the same, exactly the same examples even to some degree, because this is a Pearson book, and I think the quant book is Pearson as well. But I do want to cover it, get it out there for everyone to look at and see, and then we'll go from there. But as we're going through, there we go. So in thinking about decision making, we know it's a process. We know that we use different decision-making tools based on how complex our decision actually is that we want to make. So one of the things we use is our decision tables, and they'll give us some ability, and then for more complex or multiple decisions based over a series of events or a series of decisions, that would be in decision tree. I think today what we want to talk about as much as anything will be actually how we do this. But when we're thinking about decision-making trees and tables, let's see, well, this is just what we're going to do in the chapter. We don't need to go with that. That's what I want to look at. So the process is always, no matter what we're trying to do, the first step of any process is to figure out what it is we're trying to answer. What's our issue that we're having? What are we trying to come up that will help us solve that issue that we're having so that then we can make a proper decision? We develop a model, we evaluate the alternatives, and we select the best alternative. That's exactly the same decision-making structure as what we had in Chapter 3. We talked about that last time. When we're in all of our decision-making models, we're going to be looking at the alternative options that we have for us, as well as the state of nature. And the state of nature is an occurrence or a situation over which the decision maker, that would be you, have very little control. So in other words, what's going to happen? Well, we're not necessarily positive on that. And based on how positive we are is going to help us figure out what it is, how we make this decision in the first place. This is when we get to a tree. We're not really there yet. A tree example. The decision node is a square. State of nature is always represented as a circle. But I think I want to start with the table so that we can make a little sense of that. So anytime we have a decision-making table, well, we list our alternatives down the right side, or left side, and then we list what we suspect we're going to actually be able to make, or our payoff, across the top. When you're examining these, those are also called states of nature. So that would be something that you can't necessarily predict, but you're going to attempt to. What type of things might we be looking at? In this case that we're going to work through today, we're looking at a scenario where we either choose a large plant, a small plant, or no plant at all. And we're going to try to determine which one of those is best under certain situations. So which one would be the best decision in a favorable market, and which one would be the best decision in an unfavorable market. To determine that, we're going to, anytime that we are, well, I think I have a slide that talks about this. Yeah, here's what I want to get to. So this is where I want to spend just a couple of minutes and add some things that you probably haven't actually heard. We know from quant that decision-making under uncertainty is when you don't have a probability. When you have a probability, that means you're assigning some kind of risk to it. Now, let's think through this. If you're in a situation where you're dealing without probabilities, you don't know necessarily what's going on, that would be uncertainty. What kind of a person or what kind of a job title might the person who's dealing with high uncertainty be, as opposed to one that it's quantifiable, where we can establish risk, or it's an industry that maybe have been around a long time. What's a characteristic of someone who might be dealing in high uncertainty all the time? Any idea? Who would that person be? Would it be? No wrong answer, by the way. Let's just talk about this for a second. Think about who deals with stuff that they're always a little bit uncertain. There's never a real clear path in what they take. That might be the case. Yeah. So that would be someone who is every morning could be surprised. Even throughout the day, they might be surprised. Dealing in high uncertainty. What else might there be? What other kind of person might there be? And what would they be associated with? So think about it. What's predictable versus what's unpredictable. What's predictable is what? Something that it's been repeated a bunch of times. It's an established industry, or very predictable as far as we know how this is going to work all the time because it's got a long history, as opposed to uncertainty would be something that's what? There you go. Now we're talking. So what would that look like? Something that's unnew or brand new, innovative, it's disruptive to the current market, some kind of situation like that. Who might be dealing with that? Who does a lot of stuff with something new, innovative, not currently in the market? Who might introduce that? Who would bring that to the market? What would that person be? Reese, you know this probably from last semester. What would that person be? Who's that person that brings something new, fresh, innovative to a marketplace? Inventor is definitely one. What's the word when an invention becomes a business? What would that be called? The entrepreneur. Now we're talking. So thinking about the entrepreneur in the marketplace is the spot where they would fit in this uncertainty, as opposed to the person who might be a manager of a very stable industry or a very predictable type of situation. The entrepreneur would be someone who there is no track record. Everything they do is uncertain. So they might be even more likely to deal with the decision-making table where there's no probability. They're just kind of making a guess or a projection based on either their current experience or previous experience or whatever. But the reality is, I just want to make sure you realize what we're talking about here. That entrepreneur, whoever brings that innovation to the market, is the one who's taking the risk. And why would they potentially take the risk? What's that? What's the higher reward? And what would the reward be? Money, capital, maybe freedom, maybe flexibility in their schedule. Maybe they don't have a boss. Maybe they're their own boss. Their boss is only the customer. Whatever the reward is, that's why the risk, the potential payoff, would be why the entrepreneur would take the risk. So I just wanted to touch base on some of that before we get into it, because that really sets apart why it brings to the conversation the big picture of who's taking the risk and who's actually working in more of a stable, predictable environment. Okay, so uncertainty doesn't have a probability. You can't assign a probability. So what does it mean if I'm able to assign a probability? Well, I've got a track record of some kind of numbers or previous results that I can go by, and my probability is based on what's previously happened. And again, that just goes back to force. Without any ability or no history, then I can't assign a probability. All right? I know you know that, but I just want to talk through it because that helps me to be clear on when an entrepreneur might be at work. So if we're in an uncertain environment, we're going to use something called a maximax potentially. or we might use the Minimax. But the Maximax would be someone who is what? As far as their personality type, maybe. What would this person look like if that was picking the Maximax? Probably. Yep. They're optimistic. They believe the best is going to happen. They think that that's the case. Whether they're that way all the time or just for this particular story, they come to this situation thinking, oh, it's going to work out, no matter what the story is. So that would be the reason that I would choose the Maximax technique, or the Maximax actual number when I calculated it out. Contrary, the Maximin would be the person who would be thinking, that would be more like the person who would ask a lot of questions. They want everything figured out before they even step out the door. They want to know what the forecast is. They want to know what the chance is that this is going to work. They want to know, who can I trust in this situation? They're much more along the line of taking a lot of time, being very analytical, and they can really become pessimistic or a protectionist view. That might be the person who uses the Maximin. And again, they're trying to protect themselves and get the least possible loss if it is going to lose. Equally likely, just what it is, it's basically an average. It's the idea that either one might happen. If chances are 50-50, which one would I choose? Which one would make the most sense? So again, this is the kind of story where in quant, we look at more like a Hurwitz or weighted average and those kind of things. But in this way, we're just going to look at these three examples: the Maximin, Maximax, Maximin, equally likely. If you're doing a Hurwitz or a weighted average, you do that out just keep the table going to the right. But in this case, the idea, the example we're going to work through here in just a minute is we think we want to expand, but if we expand to a certain area, we have two options. We can either build a large plant and really reap a lot of rewards if everything goes well, or we can build a small plant, kind of work into it, test it a little bit before we go on to the large plant, or we can just do nothing and maintain our status quo. So that's what we're going to work through here as we go. Let's see here. Okay. Now, conversely, if we don't have a probability, we're working with uncertainty. When we do have a probability, that's called decision making under risk, or that's also coincides with, can you assign a probability to it? A lot of times in entrepreneurship research, we talk about, if I know enough about a certain thing that I can actually assign a probability, then some people say that's not entrepreneurial at all. Others still say, well, just because you can assign a probability, you may still be bringing something new and innovative to the marketplace. That's just a debate going on, but that is ongoing. And I don't know that I have a role. I'd probably lean toward, if it's entrepreneurial, you can't really assign a risk, just because I think that more captures what the market value of the entrepreneur is trying to do. But either way, if you have a risk, then you have a probability. And when you can assign a probability, use the expected monetary value, EMV. And so that's a different calculation that we'll look at here in just a second. The expected monetary value looks like this, and I think that's more confusing than when we get into Excel and we can actually look at what's going on. But basically, it's equal to the payoff of the first state times the payoff of the first. Well, let's see, the first state of nature times the probability of that state of nature, because we know the probability, and then you add all those together, and that's what gets your EMV number. So in this case, just looking through it, the favorable market, we think that that we can gain $200,000 if we construct a large plant. That probability is 0.6. So we would group this together, 200,000 times 0.6 plus, what if it goes bad? 0.4 times minus 180,000, and then we get a total of 48,000. So that's one scenario, and then we basically are going to pick the one, whichever one in the EMV value that winds up being highest. Because we didn't do anything in number 3, then we're not going to expect any gain. But when we do this calculation in B, or the second option, that comes out to 52,000, so that's our best option in an EMV. We'll look at that closer in Excel here, and that'll make more sense. And then the last thing we're going to look at is there is no such thing as perfect information. We realize that. But if I can get more information to help me make my decision, I've got to figure out a way to determine, well, if I spend X amount of dollars to get new information or more information, trying to get to perfect information, how much is that really worth? And so our last calculation, we'll look at that, and we'll try to figure out, okay, give me a value of an expected value of perfect information, and if that's the case, then I know whether to actually try to get that better information or whether just to stick with what I have. So that's the last thing we'll look at. Okay, and the expected value of perfect information is the expected value with perfect information minus your maximum EMV. And so once we calculate the maximum EMV, then we can work back and we can start looking at what this cost would be toward getting perfect information or better information. I don't like to use the word perfect. We know there's no such thing as that. But the idea here is that if I'm going to do a study or if I'm going to do some market research or whatever, it's going to cost me something. And so when I say perfect value, perfect information, it's my attempt to gain more perfect information, even though I'm not ever going to gain particularly perfect information. But I'm going to spend something, even if I don't get 100% optimal perfect information, even if I only get 80, I've improved what I knew before, and that's going to cost me something. Is it worth me pursuing that better information to go ahead and spend the money? Okay. And again, this will make sense once we get into Excel. Okay. So an information tree. We talked about an information table. That's what we just went through. An information tree is what uses those decision nodes and those states of nature. And again, they're used when we have more than one decision that needs to be made. So we make a decision, it leads us to another decision, it leads us to another decision, or whatever. But it's for a more complicated scenario where it's more than just one. And a complicated one, again, we decide to define the problem. All that's basically the same. Except for here, we're going to actually use the probabilities. And here's an example of what that would look like. So again, the decision node is here. State of nature is the circle. And then we just basically fill in this story that we're telling that we know from our numbers before. We calculate our EMV and we work through here. When we always start on the right, we'll get into that here in a second too, when we get to the deal. And that's what we're actually going to look at here in just a second. Okay, so let's go ahead and pull up our Excel sheet and work through a little bit of this decision table. Everybody up? Okay, So now that we're all pulled up here, let's take a look at this. So if we are going to calculate the maxi max, first off, what is that one associated with? Being what kind of personality?
Optimistic.
Optimistic. Maybe put that up there just so we know who that is. So if we want to know the maxi max, and we're looking for the maximum of all the potential alternatives, right? So to get that figure, we might do a max, and we can do it this way. Oop, I'll hit enter to capture. Enter max. You can either use your keyboard to click, or you can type it. Then one way to do that is we know that these are the two alternatives for the maxi max. One's in favorable and one's in unfavorable. You can just grab both of those with your arrow and highlight that box, and then it'll show up over here in your formula. And then when you close that, that's your that provides your answer. That's one way to do it. You can also hold down Control and then it'll put a comma between them, however you want to do it. But if they're right in a row, you can just pull them across. So in that case, we know that our maxi max with the large plan alternative is 200,000 best potential. We also can do this. We don't need to retype that formula since they're the same and everything's in the same place. So we can just pull that down. And we can also have it calculate for the small plan and if we do nothing. Now to get our decision, or to calculate the fine of that, we want to know what the best of all of those are, right? So this is going to be equal to, the final result is going to be equal to the max of all three of these. Right? So something like that. You see that? So if we do the formula, then obviously we can fill in all the blanks and know what's going on. Conversely, on the maximum, we know that's what's that type of a scenario we're associated with? More of a pessimistic approach, right? So in a pessimistic approach, what is it we're trying to do? We're trying to minimize our exposure, trying to make it where if it does go bad, we lose the least as possible. So that conversely would be equal to minimum, and then we're going to look at if we pull that down. So the minimum in each of these, the worst case, the bad thing that's going on is the minimum, and then we know we want the best of the minimums, right? That's how you determine the maximum. So again, you can just grab this one before in that cell and pull it over, and that should drag that one over. Because you're still trying to find the best alternative, the least problematic. And that's what the maximum will give you. So what's equally likely is just our average. Just I like that, just so I know what they're thinking about, thinking through. In reality, so that's going to be average. Equal to average. I don't know why that wasn't started. There we go. So you can just select average as an option, and then you're going to take those two. So my equally likely average is $10,000, and if I pull that down again, that works for the formula for all of them, and I can pull this one across one more time. Whoop, I didn't do that. I have to grab that box, pull it across. Yeah. Okay. Now to calculate my EMV, and again, this is my this is what I'm actually after. This is again the one that takes in the probability, the expected monetary value. So we're looking at the first three were in uncertainty, and then this last one, the EMV, is the risk. That's where EMV comes in. Okay. Let's see. We can do this. I mean, basically, what it is it's the EMV is the payoff, whatever we think we're going to get paid, times the probability, and then plus the payoff times the probability of each condition, however many market conditions we have. We could have 2 in this case, or we could have any number that we want. There's a way to do that in Excel that's a little bit easier. If you'll type equal to sum, and then select this sum product, that will allow us some help there. So it's going to be, see, it's talking about array 1. So the first one is it's going to say pick this array, and then comma, and then your second array is going to be these probabilities right here. So let me click that, and then you can. So when you have the array, you pick the top line, and then you pick the probabilities, and that gives you your. So here's that formula one more time. That gives you your EMV for the top line. Now we can't pull this down because that's going to grab all these in between here, and that won't work for us. So we need to make in order for us to drag things down, we need to make the probabilities absolute. And the way you do that is if you click in there on the B6 like that, and you click F4, it throws in these absolute signs. And then you click on the F6, click F4. So now we've created. Oops.
You can hit the undo arrow. Yeah.
So F6, F4, and C6, F4, and that will give us these absolute values in here, right? And once we have that, oops, then we can drag this down. And what it's going to do then is it'll grab these cells where they are without trying to grab them over here. And then it will, because we have it absolute, and then it will actually give us our EMV for the other 2 alternatives. So let's go back through here and make our decisions. We made our decision in step 1 with the Maximax. We probably could have written it down then. But the Maximax decision is to build which plant? Okay, so let's just go ahead and put that in our. Maximum decision is to do nothing, right? equally likely decision is to build a small plane. Got to pull that over on the MV. You can still pull that over from the one on the left of it. It's the same formula to get this, the max of all the options up there. Because we always want the max, the best one of all the options. So that one is what? The the EMV decision is to build the small plane, right? So in thinking through this, here, one more thing we can do is we can try to figure out, okay, what's our story as far as perfect information goes. So if I come down here and I'll just say, well, let's see here, if I'm looking for the value of perfect information, what is it I'm trying to determine? Well, perfect information is the expected value with perfect information, right? That's the first one.
Excuse me, would you like bigger? Yeah, this looks like the corner of the electrical circuit.
Okay. That's not a little too big. So our expected value with perfect information, and what we can determine there is that we want it to be. Remember, it's the max of all the alternatives times their probability. So let's put that over here and just do something like equals max, and then we want to go up here and select these first alternatives. So that would. I did that wrong. That one should be equal to the max, and we want to go down to all these options right here. So B3 through B5 times, and then it is our probability. Sorry, I've got that so big we got to move around. So times our probability plus our plus the max. Again, we're going to pick this one, those three. Times that probability of 0.4. So if those cells are the same in yours, the max of the all the outcomes, or all the possibilities of a favorable market times its probability plus all the outcomes of a negative market or an unfavorable times its probability in 0.4, and that should give us B3, B.
W.
Oh, I gotta start with parentheses, that's what it is. Yeah, there we go. So this is my expected value with perfect information. So then I need to know what's my expected value without perfect information to compare those two. And that is by, when I'm trying to figure out that, that's the number, that's basically all that is the EMV that I already calculated. So, because I know that's my expected value, base case scenario with all my averages. So that's just equal to, over here, equal to, I gotta get that out of the way, so hold on. I'll get this back in. That'll be equal to that G. That's not, I'm not marking place. Okay. Here we go. Okay, this is equal to, and it's, if you've got it where it's not so big, it's just equal to that cell here where we calculate that EMV. Right? So that's 52,000. And then our expected value with perfect information, our EVPI, is just it's going to be equal to this minus this. Right? So let's go ahead and put a box around that just so we can tell where we're going. And highlight that one. So what's the EVPI tell me? What's this number going to be telling me all the way through? If I have to figure out, if I think I need more information to determine which one of these alternatives to select up here, it's all the way down. Get this where we can see it all a little bit better. If I think it would help me to determine which alternative to pick and whether to use whatever strategy going forward, and I need to, if I think it would help me to acquire information, what's this number right here telling me? It's telling me I can't spend any more than that. That's the very max that it could possibly be worth. So whatever I do to acquire this, whatever I believe additional information toward perfect information that's going to help me make this decision, if I'm over 68,000, just don't even bother. And that's a very important thing to figure out up front, because like if you got to hire a national firm to research or whatever it is you need to do, you're going to be able to probably figure out, okay, what's it going to take me to get this information? And unless I know what's the maximum that information could be worth in my scenario, then I don't have anything to work with. So until I know what's the maximum possible that I can spend, then I can't really talk about getting new information. I don't know if it'll help me or not. Okay? Okay, let's go ahead and work on the decision tree. Well, let's go back and see where we were in PowerPoint. Well, let's go ahead and do the decision tree as long as we're here. So, when we're doing the decision tree, it's basically the same numbers that we had before, except for this time it's going to involve more than one decision. And you always start on the decision tree on the far right. So we have this information up here. These are the exact same numbers that we had when we started. And what's going on here is this one is allowing us to, let me get this smaller so we can see it all. We're trying to determine we've got this chance to do a market or a market research survey. And we're trying to ask the question, we know it costs $10,000 for this company to do this research. We're trying to determine, okay, in all these scenarios, is it better for us to do the survey, and then if it's an unfavorable or unfavorable, and then, or is it better for us just not to conduct the survey? Would we be better off in deciding which one would make the most sense? These are hard to see because we got to zoom way out here. Or let's go in a little bit farther. And then so what you do, then you move from, okay, let's say we're going to conduct a survey. So we go up here to this, this is a state of nature. These circles are states of nature. And then we move to another decision node. So we're starting with the decision, conduct market survey, don't conduct market survey. Let's just work on this top part since we're here. Then we get a state of nature, and the market survey has a state of nature that says there are favorable results, or we found out what we wanted, or they're unfavorable. So that's a state of nature. And then we get to another decision tree, or decision node, and it's saying, do we do a small plant with a survey, or which plant do we do with a survey? Which plant do we do with a small survey? And then both of these are, all of these are the favorable, unfavorable markets that we talked about before. And then this line here is our probability that came from, that were given us to start with. Okay, so how we do that is we always start with these same scenario back over here to the far right, and it's the same numbers that we had. If we didn't have this survey, then it would just be equal to this number right here. But because we're going to do the favorable market large plant first, that's the one this one is. This is the large plant leg, favorable. So it would be equal to that, except for the fact that we already spent $10,000. So we've got to factor that into this far right scenario. So we need to minus that $10,000 cost on all of that, on all of this stuff up here, this top node, this top branch, this top tree that is including the $10,000 market. That make sense?
Excuse me?
Yes.
Read the last step.
So it's
Equal
to, and then the large plant number is 200,000. So click on that cell, minus, and I clicked on this 10,000. So you have 200,000 minus 10,000. And then the next one is this unfavorable. So we've got a, that's going to be equal to the unfavorable minus 10,000. And so we could do this. Oh, that didn't work. So this is equal to the favorable oh, I hit the wrong button. There we go. B4 minus 10,000. Is equal to the unfavorable small plant minus 10,000. Is equal to the do nothing. So that's going to be equal to that. But we already spent 10,000, so we still have to put that in. So that's the 0 minus 10,000. And that's the same on both. 0 minus 10,000. Then we could go back to the other, but let's just do it. This is going to be equal to that favorable large plant minus 10,000. These numbers are going to be exactly the same, by the way. These are going to be equal to unfavorable minus 10,000 equal to favorable small minus 10,000 equal to unfavorable small minus 10,000 equal to do nothing favorable minus 10,000 and equal to do nothing unfavorable minus 10,000. And so just checking real quick, they should be exactly the same. There's a different probability. Okay. Now then, down at the bottom are that's going to be the large plant large plant favorable, so that's just equal to this. We don't have the 10,000 in that one. We didn't spend the 10,000 down here, so that's going to look like that. And then they're all going to look just like we did in this is large plant unfavorable, large small plant favorable. Small plant unfavorable. Do nothing. And do nothing. Favorable. So these numbers look like this. You see that? What you're saying? Sorry. Okay. So now working back, when we go back up to the top of our model, what are we trying to find? Well, the first thing we're going to look at is our EMV. We know our EMV is the each condition times its probability. And so that is going to equal the choice of it is going to equal this EMV is for the option 1, and you can see option 1 has both the favorable and the unfavorable. So we're going to write that up here. So what we need to combine is that's going to be equal to so up here I'm equal to, start my parentheses, it's this times this, or I can do 0.7, it doesn't matter. Or I can, and then plus parentheses. So for each, the 0.78 times 190, 0.22 times 190, minus 190, then I get 106,400 in that top EMV. I'm going to go ahead and do this again because I did it backwards. Doesn't matter, but I just want to make sure it's the same before I copy it. Times 90 plus, open parentheses, 2.22 times minus 30 is going to give me 63.6. I think you should work in order just to copy that down here and paste it, but let's try it. Make sure that that formula matches. 12, 13. Yeah, so I think that's good there. So we can just copy and paste that down.
That one is one you go. Divide by two.
So copy those down. I don't know, my board's down here too. Yeah, that's where. Control V to copy and paste or paste. Okay. So that's our EMVs for all these options. Now, in our decision here, so let's go back to the top. We're at this top part. So we have our expected monetary value for these options. And remember, we want we're considering in this decision whether to use a large plant, small plant, or no plant. And that decision is based on which one is the max. And then you can just hold control down these three. Close that off.
Of which three? Oh,
The top three is the 106 4. We have three. We either large plant, small plant, or no plant.
Can you just make that a little bigger?
I can. Remind me to. And that was my formula. Equal to the max of these three, 1, 2, 3. And that's for this decision then. So that would be, that decision is based on the idea that we are conducting a market survey and the survey results are favorable. That would be a decision up here in this session. Now this decision right here would be the max. We're going to conduct a market survey, but the survey results are unfavorable. We're going to select, that's going to be equal to the max of these three. Can you hold down? So 4, 5, and 6. And that best one is going to be so what do we decide up here? In this case, if we decide to conduct a survey and our results are favorable, which one are we gonna select? The large plant, small plant, or no plant? Large plant. Conversely, if we're gonna conduct a survey, we decide to do that, survey results are unfavorable, we're gonna select which plant? Small plant. Yep. All right, so now let's go down here and make this decision. That's also going to be equal to the max of these three options. And so you can hold your control down and just select them all. That. So what is this telling us? In this scenario, we decided not to do the survey. And we decided that if we don't do the survey, the best option is still the small plant. That's right? So now we need to go back one and go up there to that next place where we make a decision. And that is right here. I should have done this before. So anyway, on the favorable, unfavorable, so again, I've got to try to. I forgot to do this, but my EMV here is to look at G8 times its probability, and they gave me this probability right here. I've got to do that. So that's gonna be equal to, this G right here, G8 times this probability, wherever that goes right there, plus this times 0.55.
Do these make it bigger so we can catch the numbers?
All that on the screen.
And can you open the phone?
So that's equal to this 106 number up here times its probability of 0.45 plus this number down here times its probability of 0.55 for the 49,200. So now let me go back out here so we can kind of look at that and decide what we're deciding. And so in our case here, this is an EMV for whether we conduct the survey or not. We'll use this number to compare to this number. Because the last decision is based on whether or not we should work up here off of these two, because this is factoring in both of these. Whether we should use the max of this one versus hold the control down, that one. So we factor in doing a survey with good results, bad results, or unfavorable results, all the way back to here, and then we compare that to not doing a survey at all. Which one should we do?
Not a survey.
So don't do a survey at all. So that's our decision tree. Any questions on that?
Can you look at the last one more time?
This one here?
Yeah.
Yeah, that is equal to the max of this and this. Does that make sense? Wherever that is. That 52,000 down there at the bottom. There we go. So it's equal to the max of those. Okay. So now let's look at the one other thing on this. What we can look at and kind of make some decisions based on that. If you pull down, I've got a couple of blocks ready for us to go. So what's our decision? Our ultimate decision is to, best decision is not to conduct survey. So we thought at first that it might be worth $10,000. No, we can't answer that one yet. Let's calculate this value here, like we did previously, of what is our, and I get that where you can see it better. Can you see that at all? So that the estimated value of perfect information. So let's do this. Let's go ahead and calculate that. Let me get my thing pulled down so I can actually see it. So first, the estimated value with, we're going to put survey, just so we can make sense.
Can you zoom that in?
With our survey information, okay? So what's our value with survey information? And the way we're going to calculate that is we're going to, this is getting tricky to get all this going on the same screen. So it's going to be that 49,000 plus this is gonna be equal to, we gotta go up here, grab that, plus the 10,000 that we spent. We get it right there. That make sense? So that's the estimated value of the information, of the survey information. It's that final payoff, plus that, the $10,000, because we didn't really spend it. I mean, if we're thinking about it, we haven't spent it yet. Until we spend it, we haven't spent it. So that's why we have to add that back together, back in. The expected value without the information, without the survey information. And in that case, what that's going to equal is going to be that 52,000. So that's going to equal this right up here. That was our value without information. And so then our EV with the estimated value of the survey information is this is equal to this minus. So if we're thinking, then the question over to the right of that box says, so it's going to cost $10,000 to do the survey. Is it worth it? What's our answer to that? No. Yep. And let's say, no, it is not. Something like that. Not worth it because the estimated value of survey information is only $7,200. Was that clear as mud puddle? Now, the appendix B, whatever the, I'm sorry, what are we doing? Appendixes? Is that how? Or
This is modular.
yeah, but then you have your homework that's Appendix B, right? We're getting ready to turn that in. Okay, let's look at Appendix C too, because I want to have you do that by next Tuesday when we come to class. So you'll do one tomorrow, which is the one we put off, and then the one that deals with this information on next Tuesday. So let's pull that up real quick and look at it and see if there are any questions.
Are we going to turn in the example we just did?
Yeah, go ahead and turn that in. Either, I think you got a day or two to do it. That, it's exactly like what we just did. That would be good. Well, let's talk through this one. Michael has the following options in his coffee shop, analyzing expected profits for each alternative, given the possible states of nature. The possible states of nature in this one are cold weather versus warm weather. The alternatives are which drink are you going to serve. Once you do that, it'll be kind of interesting because you'll put in those expected values with the maximum, or maximax, maximum, and equally likely, and then your EMV. You're going to give an actual determination of what you think Michael should serve based on the total potential. And I'll follow that deal. Oh, let me give you one hint. You'll have a simple, where does it say? A simple decision tree. That got people humped up a bunch before because they were trying to do 3 different decisions like we did in class today with all 3 of those. You're just going to have one of those. So you're going to have these alternatives. Once you figure out, you're going to offer lattes, cappuccinos, or iced lattes. So that's only three alternatives. And then a state of nature will be warm water, cold weather, warm weather. Make sense?
So you only have to make like one of these.
You're only going to make one of those. Yeah. It's only one decision, and that's which one of these do you serve. Much simpler than what we did in here. But that really caught people up trying to do that more complicated than it needed to be. Okay? All right. If you don't have questions, I can say, I'm done. So whatever